Okay, so in question number 6, we have, okay, so you decided to add the race variable to the model. Okay, so we have our main model and then we decided to add to it race. And then I'm giving you kind of a hint, knowing that Arcadia High School, there is a lack of real diversity between students. Okay, so is the coefficient of the variable race statistically significant and whether the result is expected? So you decided to add race, and once you add race variable here, I'm just trying to make your life easy and I haven't green like whatever we're doing, I'm writing it in green. And then when you look here, you find that race variable is statistically insignificant, right? So the t-statistic is less than all conventional levels. If you choose the 10%, which is the worst case 10%, the critical value would be 1.645. You find that this number in absolute value, 1.37, is less than 1.645, which means that you are in the acceptance region. So you're accepting the null that this coefficient, or you're failing to reject the null that this coefficient is statistically um, significant, or it's equal to, or you fail to reject the null that it's equal to 0, right? If you even look at this one is telling you 17.5% probability that the null is true. And what is the null? The null is saying that this one is, or the expectation of the coefficient of race is equal to 0. And this one again is confirming because the confidence interval goes from negative to positive, which means the 0 in between. So the three tests will always go together. They will always give you the same answer. So it's up to you to choose which one you want to depend on. Okay, so so the answer is right here, C. The coefficient of race statistically insignificant, and the result is expected because we don't have actually any real diversity in the school. So that's why it is expected. The next question, again, you decided to add the race and knowing that you have a lack diversity between students, and then based on the results of including race variable, what is your decision of including this variable? So this question is not a static question, it's just depending on your results of the regression of the previous model. So of course it makes sense that you don't need to include this variable because you don't have actually any real diversity in the school between students. So there is no need for this variable. It's statistically insignificant. So you can drop it from the regression. Next, which is question number 8. Okay, suppose you want to add the variable AP. Remember that your regression has AP English and AP Math, Gender, GPA, and then we decided to drop race, so we're going to stop up to GPA. What if you're going to add AP to this model? Knowing that AP has high collinearity with these two because it's actually made out of these two, right? And I'm giving you like a hint here, which is simply a linear combination of two variables, AP Math and AP English. Okay. So you decided to add this variable. Let's see it here. This is adding the variable. This is adding the variable AP. So let's run this regression and see what's going on. So once we run this regression, which is adding the variable AP to our model, which is this one, as you can see, this variable is statistically insignificant, right? The t-statistic is 1.43 only. And that means that it's statistically insignificant. And the result is, of course, expected because from our correlation table, which is right here, the one like the third question, we already know that there is a high correlation between the AP Math, AP English. So if I decide to put this with these two variables, which is actually made out of these two variables, then I'm kind of creating multicollinearity in my model. Okay, and accordingly, uh, I should expect statistically insignificant result. The question is, after you add the AP, what econometric problem appears to exist in this model and why? And as I mentioned while I'm talking now, it's imperfect multicollinearity because AP has the highest correlation with AP English and AP Math. Next. Okay, so again, we're asking about the same variable, which is AP, and I'm repeating again the same thing. I'm adding it to the main regression, and you're asked to estimate. I'm asking you here, so this is the new part of the question. Based on the econometric problem you identify, how you remedy this problem, like what are the options that you can do in order, what is the possible solution to this imperfect multicollinearity. Based on the slides and based on your textbook readings, you would find different ways that you can overcome multicollinearity problem. Of course, one of them would be you can drop the variables AP English and AP Math and keep AP, right? The other option, which is I didn't include here, is you can keep your main model, which is AP English and AP Math, and drop AP, right? So these are two options. You can either have AP and dropping AP English and AP Math, or keep AP English and AP Math and drop AP. So this is one of the possibilities that you can do. Right, the last question is kind of a challenging question. And I'm telling you that, I'm just repeating again, your graduating class is 640, which shows 65 students, which is our sample, and they are randomly selected, and it's very important. So I'm not choosing like the highest scores in SAT or the lowest scores, no, they are randomly selected. And we want to estimate the model, the main model, which is this one. We want to find the predicted SAT score for student number 18 or observation number 18. So if you look at your data set in Stata, if you look here, these are observations, right? And the observations are going up to number 65. This is student number 65. Our dependent variable is the SAT, which is this one. And I'm asking you, I just chose one student randomly, and I'm asking you student number 18. Don't ask me why 18, but I just chose number 18. And as you can see, like the actual number of the student is 1,240. 1,240. This is just the actual SAT. You can consider this as Y, because this is your dependent variable. We call it Y. We want to compute Y hat for this student, and we want to compare whether Y hat that we got, or SAT hat, the predicted SAT, is higher or lower than 1,240. So to do that, so the predicted SAT for student number 18, of course, you're going to run the model. You get the predicted SAT for everyone. And then you're going to list the SAT for everyone. So when you list the SAT for everyone, right, this is the SAT that you have. When you write the predict command, you know that you will get the Y hat or SAT hat, your dependent variable, the estimated. But what we care about in the question is actually this student, right? So I need to compare between these two numbers. The actual number is 1,240, but the predicted is 1,274, right? So that means I'm over predicting what the student is getting. My model over predicts. So when you, because this number exceeds this number. So when you look here, your answer is D. The predicted SAT score is about 1,274.86 points. The model is over predicting by about the difference, which is 34.86 points, right? And that's it. All right, everyone, if you have any question, please ask me on the discussion board.